So what you're going to see is a few things that we call VBExtras. And we modeled this after TEDx, just to give just a little bit of difference and change up as we go through this. And Dr. Kimberly Robinson actually convinced me to do a TEDx in Nashville a few years ago. So she is actually going to start us off with the new VBExtra, and we'll have a few of these peppered throughout the events in the next few days. But Dr. Robinson, Kimberly, is a NASA engineer. She is the SLS Payloads Manager and the Secondary Payloads Mission Manager in the first flight of the SLS. She also manages the development system and the integration of 13 payload experiments, CubeSats for the first time going away from low Earth orbit out around the moon. And several international partners are also partnered in those CubeSats. She has a lot of awards, and I'm not going to go through them all because it would just take too long. But she did get her bachelor's in engineering at Vanderbilt and her master's and PhD right here at the University of Alabama in Huntsville. So please welcome Dr. Kimberly Robinson.
Hello, can you hear me? Am I on? Okay, great. Well, good morning, and thank you for allowing me to be here as the first guinea pig up here to perform this kind of talk. So I have spoken many times to many different audiences, never in a TEDx style, and I guess now's my payback for having talked Chris into doing one several years ago. But anyway, as Chris said, I lead the payload integration for SLS, and I've been asked today to talk to you about the future of space exploration on SLS. Well, in order to talk about the future, I always think it is wise to start with the past. So I wanted to put this up here. For those of you that don't know, that haven't been around as many years as I have, this is what it looked like when I first got to NASA, okay? And every time I see the typewriter font and the Xerox smudges, does anybody know what a Xerox is anymore? It always makes me smile, and it reminds me of some really great days when I was just getting started with this agency. And since we're turning 60 this year, I thought it was fitting to look back a little bit also. I also have a quote. No lecture would be complete without a quote from Confucius, who says that to study the past if you want to define the future. So let's reflect on our past. So we're here today to commemorate, to honor, and to continue the legacy of Wernher von Braun. He's the man that's known as the big rocket guy. Right? He's known the father of rocket technology, the creator of the Saturn V rocket. However, did you also know that he began us on a journey of payloads and payload integration? So, if you remember this very famous picture, in response to Sputnik 1, the U.S. launched a Explorer 1, our very first satellite, our very first payload. JPL put that satellite together in a little over 40 days, okay? Incredible. And not only that, Wernher von Braun and his team modified the Jupiter-C rocket to become the Juno and integrated that very first payload and launched it. So, hence became the beginning of payload integration that started right here in Huntsville, Alabama. So from there, we went on to do, putting the Mercury capsule on Redstone and other such rockets. We did science operations on Skylab. We did sounding rockets, many sounding rockets. Then we went into development of Space Lab and Space Shuttle and how we were going to do payloads on there, what we were going to provide, the facilities. And then we went out and actually operated Space Lab and the shuttle with tons of payloads on board flying for all of those flights that we did. Now, many of you were a part of that. I know I was a part of at least 6 or 7 shuttle flights myself. Now, if you can imagine, just one of those Space Lab missions that I worked on had more than 80 experiments on board, okay? International experiments, experiments from all over. So we've been doing this for a while. We've transitioned over to the International Space Station, which we've been doing since year 2000 or so. We have facilities such as Express Rack, a microgravity glove box, and others, and lots of payloads on board. Not only in the sky, but also on the ground. We've been operating the Payload Operations Integration Center here at the Marshall Space Flight Center for many years, and I was very honored to be able to set console for a number of flights. Well, that's the past. So now let's look forward to the future. So everybody knows also Wernher von Braun was a visionary. I mean, back before I was born, he was coming up and drawing ways that we would have an orbiting space station, how we would go visit Mars and other planets, right? So when I was asked to do the future of payloads, I really grappled with what to say, because our payloads are still, even for the first flight, they're still being built. They're still being assembled. So it wasn't like I had a lot of pictures to show you, right? So I took a little different tack in honor of Wernher von Braun, and I wanted to talk to you about the payloads, where they're going and what they're going to be doing. So I wanted to start relatively close, okay? 239,000 miles. Everyone knows that's the distance our moon is from the Earth. And that's where we're going to start with our first payload integration. We're going to start with SLS with the 13 small CubeSats, okay? They're small sats. They're about the size of a large suitcase, okay? And we've been working with them for several years now, and we're getting ready to launch them. They have their own missions. Some of them are going to the sun, to an asteroid. A number of them are going to the moon. One is even landing on the moon, okay? But we at SLS are taking them and deploying them into deep space so they can begin their journeys of a few months to years at a time. From there, we plan to go on to EM2, our second flight of the SLS and the Orion vehicle. In that, we'll have our most precious payload, although not true payload, but we'll have 4 brave humans that will go into space. And they will go further than humans have ever gone. We'll be picking back up where we left off with the Apollo program. So we hope not only to get them to those distances, but we hope to bring them home safely in the Orion space capsule. Now, from there, we had a great discussion this morning about a relatively new development that we're all hearing about called the Deep Space Gateway. Now, I know it's still in development. We'll see what all it looks like when it's done, but right now the plans are that we will take the large elements of the Deep Space Gateway and position them in cislunar orbit, right? This will be our outpost for lunar sorties to the ground you just heard about. And it will really form our proving ground for our future missions, which we get to our ultimate destination. And our ultimate destination today, October 24th, is 68 million miles away, right? Sometimes closer, sometimes further. That's what it is today. And of course, it's the red planet. So, what we want to do and what we need to do is we're going to have to integrate extremely large payloads. Payloads that only the SLS will be able to lift and carry and get to their destinations. Things like the Deep Space Transporter to get humans to Mars. And we will also have to pre-position huge support systems to keep people on Mars. Because you don't go to Mars and stay for 24 hours, right? You have to set up shop and you have to be there. And you have to wait for the planets to align to be able to get a ride home. So that's what we will be doing. Those are the payloads that we can't wait to integrate into the future. Let's go further still. 365 million miles away. Boggles the mind. Where are we going? We're going to an icy moon of Jupiter called Europa. We're really excited about this mission, okay? So far, it seems that Europa has a shallow ice crust. Underneath it, we think there are oceans of liquid water. More water than we have here on planet Earth. And there could be habitable conditions for life. So it's a really exciting mission that we're working right now with JPL and APL on to integrate their Europa Clipper spacecraft onto the SLS rocket. But the good thing about it is, and the reason they want to fly with us, is that we have such a high characteristic energy that we can reduce their transient time to the Jovian system from more than 7 years to less than 3. That's life-changing for those people. They'll be able to actually complete their entire mission and have their data sets back before they would even arrive otherwise. Now, as a follow-on to this, we hope to also integrate and launch the Europa lander. Okay, the Europa lander will take advantage of SLS because of its enormous mass capabilities. So the Europa lander, we hope to take 16 metric tons to the Jovian system. Now, I don't know how to give you an example or a comparison, but I will say that the largest interplanetary mass that has ever been transported is 6 metric tons by the Soviets. So we'll be doing that almost 3 times over. Let's move on, though. 2.7 billion miles away. Does anybody know what that is? Come on, y'all know it. Pluto, thank you. This is what we thought Pluto looked like using the Hubble Space Telescope for a long time. And then New Horizons probe went by it a few years ago, and we got to actually see the face of Pluto. That was great. Our first photos of Pluto. Well, for the scientists, it only whetted their appetite. So now they're talking to us, there's a hope and a concept that they can go back with a spacecraft with enough mass and retropropulsion that they can actually stop at Pluto. You know, that's the problem in space travel. Sometimes it's not getting going, it's stopping where you want to stop. And so they can actually stop and spend time in orbit around Pluto and really study that planet in depth, more so than just the teaser photos that we got. Let's go a little bit further still, 11 billion miles. At 11 billion miles, we leave in the heliopause of our solar system and go into interstellar space. As you all know, what was it, 6 or 7 years ago, you know, the Voyager spacecraft that was launched 35 years ago, older than most of the people in the front row, it actually left that heliopause and went into interstellar space. And it's sending us data today. I mean, that's a well-built spacecraft, right? But now what is happening is that scientists are beginning to say, wait a minute, what if we had a follow-on mission? I mean, 35 years, it's time, right? What if we had a follow-on mission with modern technology, new instruments, right? Larger payloads. What can we do and what can we get back and how quickly can we get there? So that's pretty far out. I'm going to take you another step still. Final step, go no further. 235 trillion miles. I think that's good enough for today. So what we're talking about there is looking for life. So the TRAPPIST system a year or so ago got a lot of attention because they found a star like our own star with 7 planets surrounding it, orbiting it, that's a mere 40 light years away, right? Well, the thing about the 7 planets is that 6 of those planets are in what we call the Goldilocks zone. I love that term. They're in the temperate climate zone where they could actually support life. So, how can we help this? So SLS can enable things like gravitational lensing, spectrographic surveys, right? Direct imaging. We can help. We can help build with launching the telescopes of tomorrow. We can help in getting there faster. We can help in one of our largest science priorities, our highest science priorities at NASA, and that's our search for life. Okay, so that's the future. I told you I didn't have any pictures of already built payloads, but you see where we're going, and we're having these conversations today with people that want to use the rocket and want to understand how to integrate with us and to accomplish these very lofty goals. But bringing it right down to home, to the present, to right here, to the right now. We can't do all of this future without the people in this room and the teams that they represent. It all starts here. So, we have to work together. We have to put in the hard work to build these systems to make it happen. Now, there are times when, I don't know about you all, but my everyday life seems to get in the way of my big dreams. And every day we're dealing with schedule challenges, technical hurdles, budgetary pressures, just problems all the way around. And so what I want to urge you today to do is don't let the labor pains of creation distract you from the systems that we're creating, from what we're doing, from the important aspects of what we're doing. Not saying don't pay attention to the problems, you have to deal with them. But we have to think bigger and broader. We have to stay the course and do what we need to do to get to the future that we're all building today. This future not only changes how we think, it changes us, right? And I'll tell you from a personal experience, it definitely changed me. A number of years ago, I was in high school. I was a good student, I made good grades, but really didn't know what I wanted to do with my life, didn't know if I'd go to college. I didn't know if that was in my future, didn't know if I had money, what have you. And I was told that I was getting an award when I was in high school. They told me where to show up and when. And you can imagine my surprise when a female NASA astronaut walked in her blue jumpsuit, her flight suit. She had just flown into Birmingham, and she presented me with this award. Now, I was gobsmacked, you can imagine. Not only by her and her, personal aura, but by the fact that it was an award from the Society of Women Engineers. Now, I thought I knew a lot of things, but I did not know that a woman could be an engineer. I had no idea. And considering that I was 100 miles down the road, that sounds kind of extraordinary, but I didn't. And I didn't know that there would be enough of them to form a society. I mean, what? So, and you have to understand, a female astronaut in those days was extremely rare. There were only a few of them. I didn't know there were any. But, I mean, it was like winning the Mega Millions, right? So that day, it changed my life. And I committed myself to working in the space program. Now, I'd done my 5th grade term paper on Wernher von Braun. I knew about the space program, but again, that world wasn't opened up to me until that day, okay? And I've been doing it and loving it ever since. So it not only changes, our perspectives on the world and our solar system, it changes us, okay? It calls us to be a better version of ourselves. It calls us to think beyond ourselves, to think about the next generations. Because you know what? They're going to go further still. They're going to do things we haven't even yet imagined. Not even one of our crazy TEDx style talks, right? So we do it for us, and we do it for them. So what we're really trying to create is a limitless future, okay? We have got to dream, and we've got to think of the things, and we've got to use the systems that we're building today, that you heard about this morning, to be able to accomplish that. So I have another quote. I got a couple of quotes for you. So Wernher von Braun once said that man does indeed intend and deserve to belong out there. Not only will he do well out there, and he's talking about in space, he'll do plenty well when he gets there. Okay? And then one more, Eleanor Roosevelt. She said, the future belongs to those who believe in the beauty of their dreams. So, we have the ability today to envision our future, the future payloads that we will launch on the systems we are building today. Together, we have the power to shape our future, to influence others, to bring our world a little closer together, and to change it ever so slightly. That's all.